it's difficult to erase us. Welcome to the desk of Ladyada.
Hey everybody, it's me, Ladyada, and I'm here at my desk.
Is that frozen?
Oh, weird. It has me when I was playing my music. Yeah, it's froze.
Okay.
Well, whatever. We'll get back to this is working. That's fine. We were here for electronics anyways. So I'm at my desk. I got my overheads, and today I was having some bonnet fun. So I thought I'd show off some of the bonnets that I was hacking on. I finished off, actually I had a request a couple days ago for a prototyping bonnet. So this is in black, but the final design will be like a perma prototype with like white PCB. But it's just basically a prototyping bonnet, and you can see there's like a power railing down the side, and then these are like little 3 connects. And then we finished up the Charlie bonnet, and it's got 8x16 LEDs. It's got that IS31 FL. So basically the same as the Charlie wing. We have like a Charlie Plex wing, so it's basically the same as that. And another design that we're kind of like hacking on a little bit here and there is this Laura bonnet. So this uses a Hope RFM95. Comes in 433 and 900 megahertz, and it's connected to the SPI pins. And like we thought it would be kind of cool because you could maybe use your Raspberry Pi 0 or Pi 3 or whatever as a radio gateway, and then you could maybe connect to it with feathers, and have the feathers like send data to like the main computer, like a gateway type thing. But the one I was mostly working on today, because there was actually code involved, is this little lady. This is I don't know, have really a name for it yet, but I thought maybe like Joy bonnet. It's kind of joyful, and it's a, hold on, I just want to be careful not to bend the pins. It's got a analog joystick. This is a thumbstick from like it's not actually the same thumbstick used in a PSP 1000, but it looks a lot like it, so I call it like a PSP thumbstick. And it's got some buttons here, and then
I got your computer back.
Oh, sweet. Here, I'll show it over here too. This is the Eagle Cat, and I think I designed this on one of a previous show. So it's got X, Y, A, B buttons, select and start, and then I have a couple more spots, so I put in 1 and 2. I decided not to have thumb buttons or like top buttons, whatever, it's a side effect buttons, because it would actually, you wouldn't be able to press them. It would be in the way of the HDMI and power cables on the Pi Zero. And then here is an analog joystick. Like I said, this is used in a PSP, and it actually has 1 potentiometer. So this is a 3-pin potentiometer for X, and then a 3-pin potentiometer for Y. And since the Raspberry Pi doesn't have an analog digital converter, we popped one on. I could have used like a an AppMega or something, but it was pretty easy to just use an ADS 1015. It's a all-in-one analog digital converter over I2C. So it just reads these analog voltages here. You can see the center pin here and the center pin here, and then send them off to the I2C bus over here. Very easy. There's almost no components on this. And then I made it surface mount. Mostly, can you go to the overhead real fast?
Mm-hmm.
The reason I went with a fully surface mount design is I want to make it so when you are using it, it doesn't like rough up your hands. Like I thought if this had the headers, it would like maybe scrape your hand a little bit. So I thought like, okay, let's make it a fully surface mount design here. And you can plug it onto the Pi Zero. This is one of the only bonnets that really works kind of only on the Pi Zero. But then you have just HDMI and power, and you can, let's go the wrong way. You can, game it on. So I started writing the code today for that, and so let's go to the compy, and I can show off kind of how it works. I ended up using a lot of code from we kind of merged like the retro game code that Phil B wrote with the PyCade hat script from Pimoroni, because they got all like the U input code that you need, the little magic things you need to do to get Python to send key commands. So you set up all the keys. There's a lot of just like plain Python just defining everything. And then the majority of the code in this script is the ADS 1015 interface. Again, that's an I2C analog digital converter with 4 channels. And while I could have like used, we do have a Python library that like does like every kind of conversion with gains and like samples per second options. I'm kind of going to be using, I wanted to make this script as simple as possible, and so I kind of made it like a micro driver. I basically just took the core elements of the driver and just made it so like, look, all it does is you read, values from the channels, and it gives you back the 16-bit value, and like that's it. So it doesn't have any, it's not extensible, but it does one thing. I think it was a worthwhile trade-off to not have to import multiple different libraries, and what if something changes in that library, I didn't want to affect it. So let me, actually this is the wrong version, so let me grab, reread from disk. Okay, because I made a backup of it. So I have a function called ADS read, and I have a lot of debug code because I was kind of messing around with it, but basically what it does is it configures all the flags you need for the analog digital converter, basically to do a single channel read. It writes that data, and then it waits for the I2C data to come back and say the read is done. You basically pull this pin until it's complete, and then it returns the value to you. It has to do a little bit of little endian to big endian conversion. The read I2C word command, it does 16 bits, but watch out because it might, depending on how your device thinks the byte order of a word should be, it can come back backwards. And so I ended up just using I2C block data read and write. Works fine. You just have to like take the items out of the list and then shift them the way you want them. So that's what I do here. I just shift the data, and the lower byte is actually the higher byte. So I just swap them here. And then it's a 12-bit converter, so I just drop the bottom 4 bits, and I return it. So that's just all the analog stuff, so that's very easy. And then in the main program, we load a kernel module called uInput that allows user input. Basically, it allows a program to mimic key commands. And we set up all of the pins that we're using. Remember, all of the pins over here, the 1, 2, X, Y, A, B, select, start, these are all just plain GPIO pins, just hooking them up directly to GPIO on the Raspberry Pi. And I tried to use pins that like weren't special purpose pins, didn't have like special functions. And then we, basically add event detection for each one. We basically add a callback for every single GPIO. And then this is our special function that checks the state of the pin, and then the magic here is UI write and UI send. This actually, the UI write is actually what sends the key signal. So basically mimics a keyboard. And one thing to watch out for, I don't know how I've been doing this for like a decade and I keep messing this up. When you SSH in, you're not going to get those key inputs. They'll show up on the console. So don't forget to have like an HDMI screen so you can see the key commands come in on the console. They don't show up in SSH because it's through a virtual terminal. Yeah. Anyways, every time I start the stuff, it takes me I have to remind myself don't forget, you're not going to see the key commands in the SSH terminal. You have to open up the main console. And then I have a little bit of code. Since the analog stuff, I guess I could have that be in a thread, but for now I just have it in a main loop. I'm still just kind of testing it out. I read the analog value, I normalize it. 800 is the middle, so now I have it 0 centered. I noticed that sometimes when you're messing with the button, sometimes you end up touching the pins a little bit on the ADS 1015, which gives you an IO error. So I just breeze through it. Every time you do a read, you're fully configuring the chip because you're setting that one register. So there's no actual state. So I just say, hey, you know what? Just continue and try again. Seems to be fine. And then I just check the thresholds. When I press that potentiometer high enough or low enough, it'll kick off the pins to do up, down, left, right. So the next thing I did was, let's see, let me open up another session. So I actually loaded up RetroPie, and then this is the script. So the script is running on the RetroPie distribution. I just basically just run Python. You know, once you turn on I2C, you run this and it's running. And then when I press the buttons, when I press the buttons on the bonnet, you will see I have the debug on, so it says key code, event, press release, and it even gives you like the pin info. Ftest is also a really handy tool to use. It gives you event information. Like for example, if I want to do mouse, you know, I can emulate a mouse with the thumbstick because it's very mouse-like. What's nice is this tells me like the key codes in a kind of a little more legible way. So if I press select, it tells me, you know, I've got, there you go, key space right here. And then, you know, key enter, left control, B is left alt. So these key settings, those are set at the top. So here is where you set up the mapping between A, B, X, Y, what is printed on the PCB, and what the key code is. I love UInput because it's like super easy to like interface with anything. So having run this Python code in the background, you can now interact with like pretty much everything in the world. Anything that can listen for key input will work just fine. So for example, you know, I because it's a joystick-like thing, I thought it would be best used with MAME. So let's go to the HDMI. Okay, so we've piped the HDMI from the Raspberry Pi. It's actually a Pi 3. And I can kind of, let me unplug this keyboard because I don't need that. And then I can,
You made it go to the right again?
well, no, because I thought I would hold it up.
Okay.
So I could just sort of play it. And, you know, as I'm, hold on.
That's clearly a device.
Yeah, clearly a device. So as I'm toggling through things here, I can select different emulators. So what's interesting is the NES emulator is not quite working yet. I have to figure out why. But this one is, so I can play Galaga, for example. And I think with Galaga, I have to figure out how to get it to do coin select. I don't think it does it by default. So I'm gonna plug in a keyboard. One of the annoying things is I have to eventually figure out how to get it to, like, you know, the coin add is like select and start. But once you add coins, you can press player 1. And then this is important because you actually want to make sure, like, you know, you get the kind of response time you want. But because, you know, it's going through the analog digital converter, but it's definitely fast enough, I think. I'm like, you know, killing bugs here, and I don't know why there's like the aliens, kind of weird. Oh, killed. And then you can press select start together, and I think that maybe it's 1+. I don't know exactly how you quit. I don't know, maybe I'll hit escape. These are a little bit of the things that you have to do. When we make the Pi Girl images, we end up
We're finally legitimately on Twitch. You're playing video games.
yeah. Okay, there you go.
Frogger.
So I can play. You want to play Frogger?
I already did that with you.
Yeah. Well, we can play again. So the next thing I'm going to do, now that I got this working on a Pi 3, Pi 3s are pretty easy to use. I'm going to try this on Pi 0. So that's my next step, and then just make sure I'm still getting the same performance I'm expecting. Like, it's, you know, it's not going to be as good as a Pi 3, but it shouldn't be so slow that, you know, I can't play like basic games and stuff. Go, 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 go. No! Dead. So sad. And then I'm going to kind of like get a feel for, like, you know, how does it feel to play in the hand? And then I'll probably have Phil B do like a really sweet silkscreen, because he makes awesome silkscreens for bonnets. And then I'll probably just send it off. Like, what I really like about this design is how simple it is. Like, there's not a lot of hardware going on. There's no drivers really. You know, other than that I2C converter, it's pretty much just like GPIO pins, and then that U input Raspberry Pi module. But that works pretty well. So that's kind of what I'm working on. It's bonnet update.
Okay. I have some news.
Yeah. What do you have?
Well, first, so I put this on Instagram and on Twitter and everything. This is the Adafruit Learning Companion lunchbox, and I'll just go out to this bigger view of it. And, you know, what it is your chance to shape the future. Right now it says AdaBox Learning Companion. We need better text than AdaBox Learning Companion.
Yeah.
We have ideas, but we're only so smart. Y'all are smarter than all of us put together. So post your ideas for the name of this thing.
Cyberbot.
Adafruit Lunchbots is an idea. AdaBox is already taken, so we can't use that. So, you know, we'll see. So, on the event schedule here, Ladyada.
Yeah.
You know, next week we have Chantel, Ask an Engineer. We're gonna have some guests coming in by soon. The inventor of Clocky is gonna stop by.
Yep.
Yeah, we're confirming that soon. And then we're going to do some other stuff. We have Friday, Saturday, Sunday. We're probably going to be doing some live videos and more. Mm-hmm. But, you know, please, you know, tag up pound Adafruit Lunchbox on Twitter or whatever.
Yeah.
Help us name this lunchbox.
Are you asking the commons?
Yeah. Okay. There's some questions in the chat. Do you want to answer a few? Let's leave this up. Doom.
Yeah. Well, I was thinking, does this work in Doom? But I think the pinouts are wrong.
Okay, you ready?
Yeah.
Let's speed around this. Fruitbox. That's a nice name. You ready?
Yeah.
Here's some questions. Does the joystick have a button if you press it down?
It does not. It's a thumbstick.
Next. Keep going.
Yeah, the bigger joysticks have a button like the Xbox style ones, but the PSP ones don't. They're just meant for the more rocker.
The discount code's Marigold for tonight. That's the name of a Nirvana song.
Yeah.
And then someone wants to know if you need certifications or licenses to sell a development board. Usually no, but you should check with a professional, an engineer who has released stuff.
There's also companies that do that kind of consulting.
Yeah.
Just because, like, there could be, like, export compliance or
there's
regulation.
no, like, here's the answer to all your questions.
Yeah.
Let's see. Can you do simultaneously button press?
Yeah, you can. I mean, like, each key code is handled only the press down and press up. Like, that's kind of the nice thing about having it be interrupt-based. And the way key codes work is it's not like while it's being pressed, it's sending repeat signals. It's only sends the key code down, key code up when there's a GPIO change.
Okay. Those are all the questions, Ladyada.
Good.
So don't forget, folks, you control the destiny of the name of this lunchbox.
What shall it be called?
It is up to you.
We do not know.
How do you repeat signals?
You don't. That's not how keyboards work. The repeat signal is handled by the operating system, not the hardware.
Does it buffer on the pad side, or is there a communication break? Does it buffer if there is a
No, I mean,
break?
it's instantaneous. It's like whenever you press it, that's when it occurs.
Yeah. Okay. Is there a turbo?
Yes. You can set any of the buttons to turbo.
Okay.
Fast.
All right. Well, everyone, please use the code Marigold. It'll be active until tonight. I left it running. So this is a special treat for all of y'all.
Yay.
So 10% off in the Adafruit store.
Yeah, maybe next time I'll get it working on this Pi Zero and I can do a little demo. And also I'll figure out why it's not working in. It works great in MAME, but it doesn't work in NES or Doom. Don't know why. I don't have any Super Nintendo ROMs, so I can't test that out.
Yeah. And that's pretty much it. Thank you everyone for supporting us and being part of this adventure together. That's the Desk of Ladyada tonight.
Thanks, everybody. Later.